In this lesson, we'll be looking at quadratic equations as a continuation of our WAEC revision. And as usual, I'm using the new general mathematics for SS3. All my questions are taken from there. The first one here says, solve the equation y squared minus 4y equal to 0. First of all, let me factorize this expression here. Y is common to the two terms. So factoring it out, I'll have y into y minus 4 equal to 0. Now, if a times b is equal to 0, is either a is equal to 0 or b is equal to 0 or both of them are 0. Both are 0. So if I apply that, that means y is equal to 0 or y minus 4 is equal to 0. Hence, y is 0 or this minus 4 will cross the other side, which is 0 plus 4, which is 4. Only the answer to that. And the second one says solve the equation 3x squared plus 5x minus 28 equal to 0. My approach is to multiply the first term by the constant term. 3x squared times negative 28 is negative. So negative 84s squared. I will look for two factors of negative 84 that can add up to this factor here. Now, if the number is big like this, instead of cracking our heads to get the factors, what I will normally do is to use factors of 3, which is 3 and 1, then factors of 28, 7 and 4, then cross multiply. This time this is 12, and this time this is 7. Since I'm talking about factors in x, I'll just attach s to it. Can we add these two numbers to get 5? Certainly. This has to be plus, and this has to be minus. So the factors will be 12x and minus 7x. 12x minus 7x will give us this middle term. So now that we know the factor, 3x will replace this middle term with the factor. So I have plus 12x minus 7x minus 28 equal to 0. Let's group it 2 by 2, 3x squared plus 12x, group it, then minus 7x plus 28 equal to 0. Notice that minus has turned to plus here because of the bracket that I introduced, so that if I remove the bracket, minus times plus will give me my minus again. So in the first bracket, 3s is common. 3s can divide these terms. So factor it out. 3s divided by 3s is 3s squared, rather divided by 3s is s. Then plus 12s divided by 3s is 4. Minus, here 7 is common. 7 can divide both. 7s divided by 7 is s. 28 divided by 7 is 4. Equal to 0. We have a common factor s plus 4. S plus 4. Here we pair this and this together. Now 3s minus 7 equal to 0. It's either s plus 4 equal to 0 or 3s minus 7 is equal to 0. X is equal to 0 minus 4 or 3s equal to 0 plus 7. S is equal to minus 4 or 3s is equal to 7. S is equal to minus 4, or divide both sides by 3 here, or 7 over 3. So our answer is 4 or 7 over 3 for this question. Example 15 says solve x plus 1 over 2 equal to x minus 3 plus 5 over x. X plus 1 over 2 is equal to x minus 3 plus 5 over x. First of all, let's try and clear this fraction. This is over 1. LCM of 2, 1 of x is 2x. So that if we multiply each of the term of this equation by 2x, we'll have 2x times s plus 1 over 2 is equal to 2x times x minus 3 over 1 plus 2x times 5 over x. These two will cancel these two. S will cancel s. So I have x times s is s squared. S times 1 is x equal to 2x times s is 2s squared. 2s times negative 3, negative 6s, then plus 2 times 5 is 10. Collecting like terms, we have s squared minus 2x squared plus x plus 6x minus 10 equal to 0. I collected everything from the right hand side and moved them here. S squared minus 2s squared is minus s squared. Then s plus 6s is 7s minus 10 equal to 0. I want to get rid of this minus here, so I'll multiply through by minus 1. So that I have s squared minus 7s plus 10 equal to 0. And now that I arrive at this point, multiply the first term by the constant term, which gives me 10s squared. Two factors of 10s squared that can add up to this middle term, that will be 5x and 2x. How do we add the two to have negative 7? Both of them have to be negative. So we replace the middle term with this factor, so I have s squared minus 5x minus 2x plus 10 equal to 0. I'll group it 2 by 2 minus 2x minus 10 equal to 0. The plus changes to minus because we introduce brackets. In the first bracket, s is common. S minus 5 minus 2 into s minus 5 equal to 0. S minus 5 is common. And s minus 2 equal to 0. Either s minus 5 is equal to 0 or s minus 2 is equal to 0. Hence, s is 5 or 2. That's minus 5 crosses to this side, which is 0 plus 5 give us this. The same thing, minus 2 crosses to this side. 0 plus 2 give us 2. So our answer is 5 or 2. An example, these are past questions actually. 16 and 17. Let's work on 16 first. 3 plus 5x minus 2s squared equal to 0. This times this give us minus 6s squared. There are two factors of minus 6s squared that can add up to 5. Let's get 3s and 2x. But this is minus 6s, but we're looking for plus 5. So this and this, when we multiply this by this, we can't have minus 6s. So that means this factor cannot work. We're going to use 6 and minus 1 in this case. So the factor should be 6s and minus 1x. So that I will replace this middle term with this factor. I have 3 plus 6s minus s minus 2s squared equal to 0. Let's group it 2 by 2. 3 plus 6s minus s plus 2s squared equal to 0. In the first bracket, 3 is common. 1 plus 2x. In the second S is common. 1 plus 2s equal to 0. We have a common factor 1 plus 2s, 1 plus 2s, and 3 minus s equal to 0. Either 1 plus 2s is equal to 0 or 3 minus s equal to 0. That means 2s is equal to, moving this here, that is minus 1, or minus s is equal to minus 3, dividing both sides by 2. Here we divide both sides by negative 1, so that these two will cancel. S is equal to minus 1 over 2, or s is equal to minus cancel minus that. Therefore, s is equal to minus half, or 3. In question 17, how 2s squared minus 9s minus 35 equal to 0. If we multiply this by this, that will give 70s squared. Two factors of 70s squared that can add up to this. Like I said earlier, when the number is big like this, it's not good to crack our brain. Let's split up the factors of this first term and the factors of this last term. The factors of 2 and 1, and that of 35 is 5 and 7. They will cross multiply. 5 times 1 is 5. So if we're talking about factors in x, then this will be x. And this time this is 14x. Can we add 5s and 14s to get 9s? Sure. That means 5 has to be plus, while 14 has to be minus. Since we are looking for minus 9x and 5. Oh no, this will not work. Yeah, it's working. I forgot to put minus here. This time this is supposed to be minus 70s squared. And this time this will give us minus 70s squared. Then when we add this, we will get this. So now that we know the factors, we replace the middle term with this factor, so that we have 2s squared plus 5s rather minus 14s minus 35 equal to 0. Let's group with 2 by 2, 5s minus 14s plus 35 equal to 0. In the first bracket, s is common. S into 2x plus 5 minus, in the second bracket, 7 is common. 7 into 2s plus 5, because 14s divided by 7 is 2s. 35 divided by 7 is 5, equal to 0. We have a common factor 2s plus 5. Then we group this and this together. S minus 7 equal to 0. It's either 2s plus 5 is equal to 0, or s minus 7 is equal to 0. 2s is equal to 5. Move here, that is negative 5. Or s is equal to negative 7. Moves here and becomes positive 7. And divide both sides by 2 here. So s is equal to negative 5 over 2, or 7. So 18 says solve the equation s minus 2 times s minus 3 equal to 12. First of all, we need to expand this expression here. X times s is s squared. X times negative 3 is negative 3s. Negative 2 times s is negative 2s. Then negative times negative is positive. 2 times 3 is 6, equal to 12. Taking this 12 here, I'll have s squared. Now, minus 3 minus 2 is minus 5s, plus 6 minus 12. This is plus 12. When it crosses, it becomes minus, equal to 0. Since we have moved 12 away from there, everything should be 0 here. So that s squared minus 5s 6 minus 12 is minus 6 equal to 0. Here we arrive at quadratic equation. This minus times this is minus 6x squared. Now look for two factors of minus 6x squared that can add up to this. Think minus 3x and minus 2x will give us that. But this time this will not give us this. So this cannot work. So the factors we use should add up to this middle term. And when we multiply, we should have this term here. So the only factors that can work here will be minus 6x and plus 1x. So now we know the factors. We're going to replace this middle term. S squared minus 6s plus s. We replace the middle term with this factor. Then minus 6 equal to 0. Can group this 2 by 2 minus 6s plus x minus 6 equal to 0. S is common here. S minus 6 plus here 1 is common. X minus 6 equal to 0. We have a common factor s minus 6. Then we'll group this and this. S plus 1 equal to 0. Either s minus 6 is equal to 0 or s plus 1 is equal to 0. Hence, s is equal to 6 or minus 1. When this minus 6 crosses equality, it becomes plus 6. When plus 1 crosses equality, it becomes minus 1. 19 says, if the square root of s squared plus 1 is equal to 5 over 4, find the positive value of x. Square root of s squared plus 1 is equal to 5 over 4. Now to clear this square root sign, we need to take the square of both sides. So if I take the square of this left hand side, I will be left with s squared plus 1 equal to, now taking the square of this 5 over 4 square. Now why taking the square of this? To remove the square root sign. Remember that if I have square root of a, I can write that as a to the power of 1 over 2 indices. And I say we are taking the square of both sides. So if I take the square of the 1 over 2, I take the square of it, which I did here. These 2 will cancel these 2. So that I have a. So the point I'm making is the square of this, I have square root of s squared plus 1, which I can write as s squared plus 1 to the power of half. Then taking the square of this, that will be to the power of 2. So these 2 will cancel this. When we apply the law of indices as a to the power of m to the power of n is a to the power of m times n. So this half multiplied 2, which means 2 can cancel out. So the point is, when you want to remove a square root sign from an expression, you take the square of it. That is the point I'm trying to make with all the long stories. Okay, now that we know that s squared, therefore, plus 1 is equal to 5 squared is 25, 4 squared is 16. Okay, if that is the case, if we cross multiply, I'll have 16 times s squared plus 1 equal to 25. If I expand it by distributing this 16, I have 16s squared plus 16 minus 25 equal to 0. So 16s squared, 16 minus 25, that should be 9 also, minus 9 equal to 0. Looking at this is a perfect square. 16 is a perfect square, 9 is a perfect square. So 16 I can write that as 4 square, then s square. 9 I can write that as 3 square equal to 0. I can apply difference of 2 square here. Remember, if a square minus b square, we can write this as a plus b times a minus b, which we call difference of 2 square. I can apply it here so that I will have 4x plus 3 and 4x minus 3 equal to 0. Meaning 4x plus 3 is equal to 0 or 4x minus 3 is equal to 0. Hence 4x is equal to, if I move plus 3 here, that is 0 minus 3, which is minus 3, or 4x, again moving minus 3 across the equality, it becomes 0 plus 3, which is plus 3. But the question says we should find the positive value of x. So since we are concerned about the positive value of x, let's discard this one right away and focus on this. Meaning dividing both sides by 4, and we have x is equal to 3 over 4 as my answer. And the last question here says, given the expression y equal to ax squared minus bx minus 12, find the values of x when a is 1, b is 2, and y is 3. Let's clear this board so we have space to work with. So if y is equal to ax squared minus bx minus 12. Now we are to find the value of x when a is 1. So substituting the value. By the way, what is y? Y is 3. So let me put that also. Y is 3 equal to a is 1. 1 times s squared is s squared. Minus b is 2. 2 times x is 2x. And minus 12, which is a constant. So to solve this, let me move this term, this 3, across to this other side. So 0 is equal to x squared minus 2x minus 12 minus 3. This is plus 3. When it crosses equality, it becomes minus 3. 0 therefore is x squared minus 2x minus 12 minus 3 is minus 15. Because I can still write this as x squared minus 2x minus 15 is equal to 0. So solving this quadratic equation, x squared times negative 15 is negative 15 x squared. Now we look for two factors of negative 15 x squared that can add up to this middle term. And the middle term is negative 2x. So the factors have to be negative 5x and positive 3x. These multiply this will give us negative 15x squared. And these added to this will give us negative 2x. So now that we know the factors, we're going to replace the middle terms with those factors so that the equation becomes x squared minus, instead of minus 2, now replace this with minus 5x plus 3x minus 15 equal to 0. If we group these 2 by 2, 5x and 3x minus 15 equal to 0. What is common here? S is common. S minus 5. And in this 3 is common. That is a number that divides both of them. 15 divided 3 is 5. 3s divided 3 is s equal to 0. We have a common factor s minus 5. So we'll take that, factor it out as x minus 5. Then we'll pair this together, s plus 3 equal to 0. Well, either this is equal to 0 or this is equal to 0. Therefore, s is, when this cross to the other side, it becomes plus, and when this cross to the other side, it becomes minus. Then I have example 16. This one specifies the method we are to use in solving the question. They solve 2x squared plus 5 equal to 9x. A by completing the square, B by using quadratic formula. Now, before we can use computing the square, let's rearrange this equation to form a perfect quadratic equation. So I will take this plus 9s across to this place. So I have 2s squared minus 9s plus 5 equal to 0. This is now a quadratic equation. Before we can use the method of computing square, the coefficient of s squared has to be 1. It must be 1. You cannot do anything unless the coefficient of x squared is 1. And to make it 1, we will divide through by 2, so that I can eliminate that 2 there. 2, 2. So this 2 will be done. S squared minus 9 over 2x plus 5 over 2 equal to 0. Let me move this constant term to my right hand side so that s squared minus 9 over 2x is equal to minus 5 over 2. Now the rule for using the computing method of computing squares is we add the square of half the coefficient of s to both sides. Let me write it down. That is very, very important. Add the square of half the coefficient of x to both sides. To the both sides of this equation, we are going to add the square of half the coefficient of x. In this case, the coefficient of x is 9, negative 9 over 2. Half of that will be negative 9 over 2 divided by 2. And when dividing by a fraction, let me remove the negative sign first. When dividing by a fraction, we change the sign of division to multiplication. Then we multiply by the reciprocal of this fraction. The reciprocal of 2 over 1 is 1 over 2, which is 9 times 1 is 9 over 4. So the half of the coefficient of x here is 9 over 4. We are going to add the square of half of it to both sides. The square of it rather to both sides, so that this equation now becomes s squared minus 9 over 2s plus minus half of this is 9 over 4. 9 over 4 squared equal to minus 5 over 2 plus minus 9 over 4 squared. So x squared minus 9 over 2x plus minus 9 over 4 squared is equal to negative 5 over 2 plus minus 9 squared is 81 and 4 squared is 16. When we get to this stage, since we have minus 9 over 4 squared here and we have s squared here, if we pick a term here and pick a term here, that is s minus 9 over 4 squared. If we expand this, remember this minus this square means s minus 9 over 4 times s minus 9 over 4. If we expand this expression here, we are going to get this back. So we pick a term here, then pair them together equal to, let's solve this fraction here. LCM of 2 and 16 is 16. 16 divided 2 is 8. 8 times negative 5 is negative 40. And 16 divided by itself is 1. 1 times this is 81. Meaning s minus 9 over 4 square is equal to minus 40 plus 81 is 41 over 16. Therefore, s minus 9 over 4 is equal to square root of 41 over 16. And square root of 41, we cannot take that. This is supposed to be plus or minus. and I move this to the other side, it becomes 9 over 4 plus or minus root 41 over square root of 16 is 4. So s is equal to 9 over 4 plus or minus, okay, the denominators are the same, so we can add the numerator. So my s becomes s is equal to 9 plus or minus root 41 over 4. So I'll take the square root of 41. Square root of 41 will be square root of 41 is 6.4 approximately. So s is equal to 9 plus or minus 6.4 over 4, which means s is equal to 9 plus, when we say plus or minus, that is 9 plus 6.4 over 4, or 9 minus 6.4 over 4, which is 15.4 over 4, or 2.6 over 4. So you can read it this way if you like. The B part of this question says we should solve this using the quadratic formula. By the way, what is the quadratic formula? The quadratic formula is s equal to minus b plus or minus root d squared minus 4ac over 2a. Where did we get this formula from? We got it from the general form of quadratic equation, which is as squared plus bs plus c equal to 0. So if we have this, we can form this from this using method rather of completing square. So we use method of completing square to make s the subject of this equation to get this quadratic formula. So now our equation is 2s squared minus plus 5 equal to 9x. Let's rearrange this to form a perfect quadratic equation. So I have 2s squared. If I move 9 to this way, it becomes minus 9x, then plus 5 equal to 0. If we compare this equation with this equation, a corresponds to 2, b corresponds to negative 9, and c corresponds to 5. So with this, we can substitute these values into this equation so that s, let me rewrite the equation here, b plus or minus square root of b squared minus 4ac over 2a. That is negative b, but b is already negative 9 here. I do not write equal to that. I have negative 9 plus or minus square root of negative 9 squared minus 4 times a is 2 and c is 5. All over 2 times 2 is a is 2. Minus times minus is plus. So I have 9 plus or minus square root of negative 9 squared is 51 minus 4 times 2, it's 8 times 5 is 40. All over 40. So I have 9 plus or minus 81 minus 40 is 41. All over 4, square root of 41, 6.4. So this 9 plus or minus 6.4 over 4, which is 9 plus 6.4 over 4, or 9 minus 6.4 over 4. 9 plus 6.4 is 15.4 over 4, or 9 minus 6, that should be 2.6 over 4. S is equal to 3.85 or S is equal to 0.65. We have some WAEC question here. The first one we have S squared minus 3x minus 1 equal to 0. If I multiply this by this, that will give me minus S squared. Two factors of minus S squared that can add up to this middle term. There's none. That means this is not factorizable. The only way we can solve this is either by using method of completing square or by using formula. In this case, I'm going to use formula S squared minus 3s minus 1. If I compare it with the general quadratic equation, which is as squared plus bs plus c equal to 0, a corresponds to the coefficient of s squared here is 1, so a is equal to 1. Then b corresponds to -3, while c corresponds to -1. The quadratic formula says s is equal to minus b plus or minus 3 a squared minus 4ac over 2a. Substituting all of these values, I have s equal to minus 3. I have a minus on b, but my b is already minus 3. That's why I have the minus. Then plus or minus with b squared minus 3 squared minus 4 times a is 1 and c is -1 all over 2 times 1, which is minus times minus is plus, the square root of 9, minus times minus again plus 4, is 4 times 1 times -1, over 2, which is 3 plus or minus square root of 13 over 2. The square root of 13 is 3.61. So this will be 3 plus or minus 3.61 over 2, with s is equal to 3 plus 3.61 over 2, or 3 minus 3.61 over 2. 3 plus 3.61 is 6.61 over 2, or 3 minus 3.61 is 0.61 over 2. 2x squared plus 7x minus 11 equal to 0. Again, to save time, let's use quadratic formula here. So we compare this equation with as squared plus bs plus c equal to 0. A corresponds to 2, b corresponds to 7, and c corresponds to -11. Putting that into the quadratic formula, which is s equal to minus b plus or minus 3, b squared minus 4ac over 2a. If I put all of that into this equation, s becomes -7 because b is 7 there. Then plus or minus square root of 7 squared minus 4 times a is 2 and c is -11 all over 2 times a, which is 2. So that we will have s equal to -7 plus or minus square root of 7 squared is 49, minus times minus is plus, 4 times 2 is 8, 8 times 11 is 88, and over 4. This will be -7 plus or minus root 49 plus 88 is 137 all over 4, which implies s is equal to minus 7 plus or minus square root of 137 is 11.7 11.7 over 4, which means S is equal to minus 7 plus 11.7 over 4, or minus 7 minus 11.7 over 4. This will be minus 7 plus 11.7 will be 4.7 over 4, or minus 18.7 over 4. And 4.7 divided by 4. This divided by this 1.175, or negative 4.675.